morning, grade 12s. I am Mrs. Charlotte Stein. I'm going to revise paper 1 and paper 2 with you, and I'm going to try to emphasize on the more difficult problems. You'll see that in each sum, there's a few easy ones, and then you get a more difficult question. So I'm going to do the easier ones quickly, and then I'll get to the more difficult ones so that you can make sure you will be able to do more difficult problems in the exam also. Now let's start with paper 1. That is equations. And the first question, equations, is more or less 20 marks. So people, in this question, you always have a first question which is solve for x, where you have 2 or 3 problems. The first one is always a very easy one which can be factorized. Now in this case, it has already been factorized for you. So it's already equal to 0. If there was a number there, then you will have to remove the brackets, put the number on the right-hand or the left-hand side, and factorize again, so that you have an equal to 0. But in this case, it's giveaway marks. So you take the first bracket, equal to 0, and then x will be 2. The next bracket is 4 plus x. But 4 plus x is the same as x plus 4. And that's equal to 0 again. So x is equal to negative 4. That's your first question. It was only 2 marks, but it was very, very easy. The next question, 1.1.2. They said correct to 2 decimals. Solve for x. Correct to 2 decimals. Right, people? Again, this equation must be in standard form. I did it over there. I wrote it as, I'm sorry, I'm on the next sum already. There it is, 1.1.3. No, 1.1.2 is the first one, I'm sorry. Okay, 1.1.2. Solve for x, correct to 2 decimal places. Right, people, I wrote it in standard form. Then I decided on the formula. The other method that you can always use here is completion of the square. But the formula is very easy to use. And people, please, if you have a sum where you have a problem solving the sum or factorizing the sum, please jump to the equation and do it by using the equation. Why? Because you're wasting time if you look for factors and you don't get factors. So immediately after you've tried once for factors, you go to the formula. There's your formula. Then you substitute A, B, and C into the formula, something that you people should be able to do. I'm not going to waste time on this. And then you calculate your square root, and it is 172. If you see that becomes a positive, be careful for those 2 signs there. It becomes a positive, and then underneath the line you've got 2 times 3, which is 6. And in the end, x is going to be 2 plus the square root of 172, and 2 minus the square root of 172 divided by 6, and that's your answer for 1.1.2. Let's go to 1.1.3. Right, people, there we have an exponential problem. Also solve for x. Now let's go to 1.1.3. There it is. Now people, if you look at that, remember when you do exponential sums and you've got a positive or a negative between the terms, the first thing you remember is that you should take out a common factor. Now, this is actually 2 to the x, 2 to the power 2 if you should expand it. And then you take out a common factor, 2 to the x. What is left there? 2 to the power 2. If you divide 2 to the x in here, you're only going to get 1, and that is equal to 20. No standard form in these equations. These are exponential equations. So you work in a different way. For a plus and minus, you take out a common factor. Right, people? And then I want the 2 to the x alone on the left-hand side. Why? Because on the right-hand side, I also am going to look for a number that is a multiple of 2. So let's see whether we are going to get to that. This is going to be 2 to the power 2 plus 1, that gives me 5. So I'm going to divide by that 5 on both sides. And in the end, I will have 2 to the x is equal to 4. And that means 4 can be written as 2 to the power 2. Then I can put my exponents equal to one another, and there I have my answer. X is equal to 2. The question was, solve for x. Those 3 questions adds up to 9 marks, which even the weaker learners should all get full marks for. People, question 1 is a question where you must get a lot of marks, because this question is really your easier question. Then we get to 1.1.3, 1.2 first. Solve the following equations simultaneously. Now people, you know simultaneous equations. I'm not going to waste a lot of time on simultaneous equation. I did the sum so that you can revise it, because it's always there. It's always there. It comes with a more difficult question, but it's there. This one is not very difficult, but it's a simultaneous equation where I have to solve for x and y. People, you've got to remember, if you've got 2 variables that you must solve, you always use a simultaneous equation. What we do here in 1.2, there's our problem. Number 1, number 2, we number our equations. What makes this one very easy is the fact that x has already been solved there. Normally, if the x is not solved already in terms of y, you've got to do it in this linear equation. After you did that, you go and you substitute that little one where you've got x alone on the left-hand side. Instead of x now in your second equation, you put 2y plus 3. So it's going to be 3. The x is 2y plus 3. 5. X is 2y plus 3. Y is equal to 24 plus 16y. Can you see now we've only got y's there? So it's possible now to solve the equation. Okay. So now we've got to remove those brackets and then put everything in standard form. After removing the bracket, I got that cube with 3 trinomial, what I want to say cube term. It was trinomial. Okay, now I skipped that step because I don't want to waste time on sums that's very easy. Okay, that's what I got there. And now I'm going to factorize that equation. If I factorize, I do exactly what I did in number 1. I take each of these brackets, put them equal to 0. And there I have negative 3 over 2, and y plus 1 is 0, so y is negative 1. Now I've got 2 values for y. I still need 2 values for x. Don't forget that. A lot of learners forget to finish the sum because they are so excited, because they got it right there, and now they go on to the next sum, and they forgot about the x values. Remember, if you have a quadratic equation like this one, there will always be 2 values for x, 2 values for y. So now I'm going to substitute y is negative 3 over 2 into number 1. And that gives me 0 when I substitute that. And if I substitute y is negative 1 in there, I get x positive 1. So the solution of this is, the x is 0, the y is negative 3 over 2. When the x is 1, the y will be negative 1. Now people, let's quickly go back to that, because you get this in analytical geometry quite often, where they ask you to find the point of intersection of 2 graphs. The one graph might be a straight line, the other graph might be a parabola, or whatever this one is. And then, this is not necessarily a parabola, but it's a quadratic graph. And then, you'll see when you must find the point where these 2 graphs intersect one another. In other words, where they cut one another, like this. That point there, you put the equations equal to one another, if they are both in standard form. Otherwise, you do a simultaneous equation. Right, let's have a look at number 1.3. There it is. Solve for x. But now, it's an inequality. Now, what you do now is exactly what you did in number 1.1. You just take the 6 over, remove the brackets. Okay, there, I've done it. Remove the brackets. Let's see. There it is. Okay, people. I took the sum, wrote it down. Then I removed all the brackets and put the 6 on that side. You do exactly what you did in number 1.1. And then you factorize this little one. This gave me actually negative 4. And then if I factorize this, the signs will be different because there's a negative. So I got x minus 4, x plus 1. People, when you factorize a quadratic equation, always check whether your answer is right after you factorize. Multiply negative 4 by x, it gives you negative 4x. X plus 1 times 1 is x. So what is negative 4 plus 1? It is negative 3. Check by multiplying the middle terms and the outside terms. And that should give you the middle term. This one was quite easy, but you do get more difficult ones, especially when you do calculus and you get the derivative of a cube equation. Right, people? Now I get 0 points. This is not the final answer for x. Like in 1.1.1, we said x is 4 and negative 1. In this case, because it's an inequality, we say 0 points. And then we go to our number line. Now, people, there's your number line. Excuse me. On the number line, you draw a little parabola, just a rough sketch. You look at that positive there. It's positive, so the parabola must be smiling. And it is smiling, okay? And then you put positive, negative, positive, because on that side, the parabola is positive if you compare it to the y-axis. On this side, the parabola is also positive. But between these 2 points, the parabola will be negative. Can you see that I actually drew little lines in there to show you? That is the negative part, and those 2 are the positive parts. If you had a negative there, the parabola would have been a crying parabola. I want to show you that, but it's quite difficult to show it with my hand. Okay, now we go back to the inequality. They said smaller than. So now you go to the negative part. And what is the values of x there? X will be larger than negative 1 and smaller than 4. But people, this is an AND solution. What does that mean? It means it got a starting point and an ending point. So you can rewrite that as x larger than negative 1, but smaller than 4. Can you see that? Right, people. If there was an equal sign there, what would you have done? You would have put an equal sign there also. But in this case, it's only smaller than. So negative 1 and 4 is actually excluded in the solution. Okay. Right, people, there's your inequality. Please remember this, because there's always the 5 sums that I did on this page, starting from 1.1.1 up to 1.3, are all sums that you can be sure about. It will be in your exam paper. And these will give you more or less 15 marks. Actually more. It's 10 plus 7, which is 17 marks. Please, you are not supposed to get anything wrong on this page. Right, let's go to a little bit more difficult sums here. That will also be in question 1. But because question 1, people, the last question is mostly more difficult questions. Now let's have a look. I said nature of the roots are also included in this chapter. So let's look at this one. The roots of a quadratic equation are this. Now people, can you see, let me just get another color pen. Can you see that this k minus 4 is actually your delta, because it is b squared minus 4ac. Can you see that? Okay, so they've actually given you delta. There it is. Normally, if you only have a quadratic equation, you must determine delta by using that formula. And then from delta, they can ask you questions. For which values of k are these roots real? Now, people, for real roots, what do you know about delta? It should be larger or equal to 0, but it can be larger. It shouldn't be a perfect square, because you only bring in the perfect square when they say real and rational. But in the case of real, it's larger or equal than 0. That is your delta. So now you take your delta and you put it larger or equal to 0. Solve for k. Negative k is 4. So negative k, divide by negative 1, you swap the inequality, and it becomes a negative 4 on that side. Why did I swap it? Because I divided by negative. And when you divide by a negative, you swap your inequality. Very easy. Your delta was given to you. Okay. Right, people? Let's have a look at another example of those. The roots of a quadratic equation are given by this. Okay. I used 4 different papers from different provinces to get all my examples. And this was in 2 of the 4 papers. The other papers was very easy. They said determine k, and then they gave a quadratic equation in which you had to find delta first and then put delta equal to something according to what roots you will have. Now let's have a look. I wanted to do this one so that you can just revise all of these. And this one is a little bit more difficult than the top one. Now let's have a look. The roots of a quadratic equation are given by this. So where's delta? Yes, there's your delta. 20 plus 8k. Right, and then they say, where k is an element of negative 3 to positive 3, write down 2 values of k for which the roots will be rational. Now, what do you know about rational roots? Yes, that can be 0 or a perfect square. Rational means you can write your answer as a fraction. 2 over 3, 1 over 2. Irrational means this number here won't have a perfect square root, so you have to use the calculator, and then you'll have to round your answer. But in this case, people, delta must be either 0 or a perfect square. Now, what are we going to do with that? Let's have a look. Take your delta, firstly put it equal to 0. Solve for k, and you will have k is 20 over 8. Okay, people, but they said k is an element of negative 3 up to positive 3. Now, let's just write the value of k there. Therefore, k will be equal to negative 20 over 8. And that is negative 2 and a half. Can you see that? Right, people. But now they said k is an element of that. Why did they give this? It's because they want us now to substitute into k and to see whether we can get a perfect square. So for delta equal to 0, your k will be negative 2 and a half. But k can only be one of these numbers. So which number will you choose for that one? You will say k is not going to be a half, 2 and a half, it's going to be 2, because you are only going to choose from there. And it should be smaller than that one. For delta to be a perfect square, check this one. You take your numbers here and you substitute it into your delta scale. Negative 3 goes in there, then it's 20 minus 24. It's negative 4. Does negative 4 have a square root? No. Then you take negative 2, you substitute it into there. 20 minus 60. Is 4 a perfect square? Yes. So k will definitely be negative 2. Negative 1 in there. 12 minus 8 is 12. Is that a perfect square? No. So that is out. 0, is 20 a perfect square? No. 1, 12 is not a perfect square. Put 2 in there. 8 times 2 is 16. 20 plus 16. How much is that? 36. Is that a perfect square? Yes. So people, the two values that we will be able to use here is plus or minus 2. From that one, you're going to round down to 2. Because we can't use the 3, then it will not be equal to 0. Okay? Right, people? Then they said, write down one value for k, for which the roots will be non-real. Right. For non-real roots, delta smaller than 0. People, please, go and learn these reasons. For real roots, delta is larger than 0. For equal roots, delta is 0. For a perfect square, delta should be a perfect square for rational roots. Right. And there we have, so if we want to solve the k here, we can also say k is negative 3. Round this number up. Let's see whether it's possible. They said k must be smaller than 2.5 for non-real roots. For non-real roots. So k will be smaller than negative 2.5. But we've got to fit into that numbers there. So we cannot have the half again. Smaller than that, the next whole number there is negative 3. Negative 3 is smaller than negative 2.5 on your number line. You see, this one was quite a tricky sum. So please, check it out. Make sure you can do it. Write down the sum. Go and do it again. And see whether you get the same answers. Write down the sum or close your answer and make sure you can do it on your own. Right. Now I'm going to go to another problem. And this is there's normally one of this type of sums in your paper. And this one is normally at the end of question 1. Now there can be a lot of types of questions here. It's always a surprise to see what they ask. Again, people, I got 2 of these questions from these 2 different papers. That means it's a quite important question. Right, let's have a look at 1.4. Calculate A and B if immediately you get a shock when you see a sum like that. Now, I want to say something else to you. When you do your exam paper, do all the questions that you can easily do immediately. Leave spaces for the sums where you think you're going to be stuck for a few minutes. Because you can't get stuck at a sum like this. It is only about 4 marks. So you can't use 10 minutes for a 4-mark sum. So leave it. Go on to the next sum. Go right through your paper by doing this. Leave out spaces, big spaces. If it's 4 marks, you leave 8 lines. And then when you've done the whole paper, you go back. And then you can look at those difficult sums that you couldn't do at first. Okay? People, it really works because you get confidence. You went through the paper and you did maybe 3/4 of the paper already. And now you go back to see whether you can get more marks on these difficult sums. Now, let's have a look. Look at this sum. Now, normally when we get a sum like this, there will also be a 7. Then you will be able to say, make 7 to 2012, 7 to the n, then this can be 7 to the n plus 2, and whatever there was, you also write in terms of n. But this is impossible here. And look at what you've got to have in an answer. Let's say A is not a multiple of 7. So you're going to try something else. Now, what do you remember about exponents? If you've got a positive or a negative there, you can always take out a common factor. So let's see whether we can take out a common factor. Left-hand side, I rewrote it there. Don't be afraid to show all your steps. Sometimes in the easier sums, I skip a step or two because you are supposed to know it. But when you do your paper, please don't be afraid to skip steps. Or no, do not to skip steps, because you know what, people? The markers mark according to your steps. And if your steps are all right and only the answer are wrong, you might only lose 1 mark. So why would you skip any steps, right, people? Common factor for that one. Aha! 7 to the power 2012, because that's your smallest one. If you divide it in there, you subtract the exponents. So you're going to have 7 to the power 2 minus, this goes into that one exactly once. That is over 12. And then, people, 7 squared is 49 minus 1 gives you 48. Underneath the line, you've got a 12. So what am I going to do with that 12? I'm going to divide it into the 48. Right, and that will give me 4. So now I've got this. But let's go and look at our answer. A, 7 to the power b. Okay, now we can say that that one is the square root of 212 gives you 1006 because you divide the exponents by 2. That gives you 1006, and the 4 will give you a square root of 2. Now, people, again back there, we've got a 7 to a power there, and what is that then? A. So there you have it in the correct form. A, 7 to the power of 1006. So A is 2, and B is equal to 1006. What a nice question. So if you get a question like this in exam, I hope you will be able to recognize it. Okay. Right, people. Let's go and do another one similar to that one. Let's have a look at this one. Okay, the question there said 7x plus a plus 3x plus a, 7x plus a, is equal to 28.7a squared. Now, from that one, you should know now that we are going to work with the common factor. Oh, please, people. Common factor when you have a positive and a negative in your exponent sums. Remember that. If you don't have a positive there, say, for instance, you've got 9 times 45 times 27. You break up your numbers, your bases, into prime factors. 9 will be 3 squared. 45 will be 3 squared times 5. 27 will be 3 cubed. And then you simplify from there on. But when you have a positive, common factor, common factor. I want to repeat it 10 times so that you remember it. Okay. Right, there's your sum. Now let's take the sum like that. Because in this case, it wasn't a simplification. They said solve for x. So we're not going to do left-hand side and right-hand side separately. This is an equation. If you want to solve any variable, you've got to have an equation. Okay, people, let's have a look. Take out a common factor here. It's 1 plus 3. Easy. Leave that one like that because we've got to get to that. Right, then we've got on this side 7x plus a equals 4 is 28, 7a squared. This cannot be simplified in any way, in any case. Okay, now what we do now, we want the base 7 on this side on its own, and we want that 4 to be gone. So we divide by 4. We divide by 4 there also. What happens? it becomes 7x plus a, the 4 is gone. We divide by 4 there, it becomes a 7a squared. Now people, look at this. This is 7 to the power 1 times 7a squared. So let's see what the answer here is going to be. On the left-hand side, we still have 7x plus a, but there we have 7a squared times 7, okay? So the 7's both have an exponent of 1. If there's no exponent, it is always 1. Right, people? So we can say that is 7a squared plus 1. It's 7a squared, 7 to the power 1. Can you see that? Please, people, be very careful with this, okay? Then, because our bases now are the same, and there's only one base on each side, we can put our exponents equal to one another. And that means x plus a will be equal to a squared plus 1. And now what was the question, people? Solve for x. Solve for x in terms of a. Because there's an a. You are going to say to me, I can't solve for x. But look at the question. Oh, people, that's something that I want you to remind you about also. Bring yourself color pens or color pencils. Bring yourself a highlighter or two. Because when you read a question, you must actually look at the question and then ask yourselves, what must I do? I must solve for x in terms of a, leaving the answer in its simplest form. So if you do that, you will remember when you get here and you say to yourself, but I can't solve x, you're going to remember in terms of a. So it's not so difficult. So you're going to say x is a squared minus a plus 1. Have you got that? Right, that is x in terms of a. Wonderful, people, wonderful. These questions can differ. This is the last question of question 1 normally. So if question 1 is 22 marks and this is 3 marks, why would you waste 10 minutes on a sum like this? These two. Rather leave it, come back to it later. But now, because you've seen it actually twice, the common factor idea, I'm sure, people, that you will be able to recognize the method if you get something like this in the exam. Good luck for this one. I really hope that all of you get the more difficult one right also. Then you can have 22 out of 22 for question 1, which will be a wonderful thing and a good start for paper 1. Right, people? That is equations. I'm not going to do more equations because I feel that your other topics really needs more attention. So let's go on to the next topic, and that will be, in this case, sequences and series.